Hi dear students, this lecture is recorded on behalf of Department of Chemistry. The topic for this lecture is reagent and catalysis in organic chemistry. Herewith I am going to explain about the reagent, catalysis. So the first one is, what is catalysis? A catalyst is a substance which can accelerate the rate of reaction, or one can say it do not consume during the course of reaction, or one can another say that it regenerates after the completion of reaction. So this is the basic three important terms in the definition of catalysis. Rather, I would say the catalysis are substances that can be added to a reaction to increase the reaction rate without getting consumed in the processes. They usually work by lowering the energy of transition state, thus lowering the activation energy and or changing the mechanism of the reaction. This also changes the nature and energy of the transition state. Catalysts are everywhere. Many biochemical processes such as the oxidation of glucose are heavily dependent on enzyme, carbonic anhydrase, proteins that behaves as a catalysis. Other common catalysis includes acid catalysis, then heterogeneous and homogeneous catalysis are also there. If you look at this diagram explains the progress of reaction. Reactant is converted into the product. Here you can see two different types of reactions having two different paths. The first one which shows in blue line, this is, if you look at the activation energy for this reaction is very high. It gives the product, no doubt, but the activation energy for this reaction is very high. If we are going to use a catalyst, the reactant is converted into the product with the minimum amount of activation energy. So that is the catalyst effect. So catalyst always accelerate the reaction with minimizing the activation energy. That is the important sentence. So the next one is types of catalysis. Generally we can say different types of catalysis, but here we are going to study only the homogeneous and heterogeneous catalysis. So homogeneous catalysis are always occurs in liquid or gas phase because the reactant and the catalyst having same phase, so they are generally treated as a single phase catalyst, while heterogeneous catalysis occurs into different phase. Generally it occurs on the solid phase of the catalyst. So the catalyst having different phase and the reactants having different phase, so it having two phases, so that's why it is a heterogeneous catalysis. So catalytic hydrogenation, actually what is catalytic hydrogenation? The catalytic hydrogenation is nothing but the addition of molecular hydrogen and unsaturated compound in the presence of catalyst. So hydrogenation is the addition of hydrogen atoms to unsaturated molecules resulting saturated double bond or triple bonds. Here you can see the catalytic hydrogenation mechanism. Initially the hydrogen gas as well as the unsaturated molecule both gets absorbed on the metal surface. Then in the second step, one of the hydrogen atom is transferred to the olefinic carbon atoms. In the second step, the second molecule, the hydrogen atom, is get transferred to the olefinic carbon atom, and it gets in the third step that olefinic carbon atom gets detached and it becomes a saturated carbon. So this is how the hydrogenation occurs with the unsaturated olefinic carbon atoms. So the first catalyst we are going to study is the Raney-nickel. Actually Raney-nickel is a fine grained solid compound mostly of nickel derived from nickel aluminum alloy. It is generally prepared when finally divided nickel aluminum is boiled with NaOH. It is boiled with NaOH. So heat symbol is missing. It is boiled with NaOH, and aluminum dissolves, leaving behind highly porous Raney nickel. So generally olefinic double bonds can easily be hydrogenated by Raney nickel at low temperature and low pressure. So the condition is very important. Olefinic double bonds can be reduced or hydrogenated by Raney nickel at low temperature and low pressure. So this is the important condition. Olefinic double bonds are hydrogenated at low temperature and at high pressure. So this is the example. So as I know, I said that olefinic double bonds are easily hydrogenated in nickel at low temperature and pressure. This aromatic aromatic olefinic compound is hydrogenated in presence of nickel at very low pressure, that is 4 atmosphere and 25 degrees Celsius. Only this double bond is get reduced into corresponding saturated compound. So this is the second example of hydrogenation of aromatic ester into corresponding cyclohexyl carboxylic ester. So here you can see this double bond get reduced. This double bond is reduced, this double bond is reduced, this double bond is reduced. So aromatic double bonds are reduced in this case. It is just because in the previous example the condition is low pressure and temperature, but while in this case the pressure and temperature are high. Pressure and temperature are high. Both the pressure and temperature are high. So here we can easily consider that when we are going to use Raney nickel at a very high pressure and high temperature, the aromatic double bonds are hydrogenated into corresponding cyclohexane. So that is the beauty of reaction. So in the next example, some of the aromatic nitrile compounds are also reduced into corresponding amines. So this is also important point. Students should have to remember that what is the role of Raney nickel while hydrogenation, catalytic hydrogenation. In the first example, this olefinic double bonds is reduced into corresponding hydrogenated into corresponding saturated compound. Students should remember only these things. Here it is hydrogen get added. Here hydrogens are added from the same side. So cis addition of hydrogen is taking place in all the cases. Here also this aromatic double bonds are also hydrogenated into corresponding cyclohexane. So now in this case this cyanide molecule is get hydrogenated into corresponding amine. So students should remember only these things. This cyanide is converted into CH2NH2. The next one is platinum catalyst. So actually platinum is used in the form of oxide P2O2, which is generally known as platinum black and Adam catalyst also. It gets reduced into finely divided metallic platinum by hydrogen in the reaction mixture. Generally olefinic double bonds can easily reduce in the presence of platinum at lower temperature and pressure. Due to the cis addition of hydrogen, the cis isomer is majorly formed. Here two possibilities: the hydrogen will be added from the same side or a different side also, but generally we see that the catalytic hydrogen always takes place in the cis fashion, so the cis product is major in this case. Here when the benzene is subjected to catalytic reduction with the platinum, P2O2 or Adam catalyst. The benzene on reduction with the P2O2 and ES2 in acetic acid gives a cyclohexane. So aromatic double bonds are easily hydrogenated by using this catalyst. That is again beauty of reaction. Benzene on reduction with P2O2 with substituted benzene like benzoic acid, phenols and anions can be reduced more easily than the unsubstituted benzene. This is also important point. So these are the some examples that again this is aromatic nitrile is converted into the corresponding aromatic amine compounds. Student again should remember that while using Adam catalyst or platinum catalyst, what type of changes is there. So this specific cyanide group is converted into the corresponding CH2NH2 group. In the exam, the question may be asked, write down the product. For this conversion, students should only write down this Cn into CH2NH2. Similarly, here it is, there are some conditions. If we change the condition, pressure and temperature, the different type of functional group are also reduced by using platinum catalyst. So here you can see this nitro group is reduced into the corresponding NH2 group without affecting other factors. So the palladium catalyst. Next catalyst is a palladium catalyst. So palladium is in the form of a fine deposit of metal on inert support such as carbon, alumina, barium sulfate, calcium or strontium carbonate. The activity of catalyst depends on the type of surface, inert surface used and the polarity of the solvent. Here we are going to see the first palladium catalyst, that is a name reaction Rosenman reaction, which is used in the Rosenman reaction. The Rosenman reaction is a hydrogenation process where a molecular hydrogens react with the acyl chloride in the presence of catalyst, palladium and barium sulfate. The barium sulfate reduces the activity of palladium due to its low surface area, thereby preventing over reduction. Here you can see the acyl chloride is converted into corresponding aldehyde by using palladium BSO4 catalysis. While this benzene chloride also reduces into corresponding benzene. Generally, when we are use organic catalyst, the reaction does not stop here yet. It further reduces into the alcohol, but by using palladium catalyst in presence of BSO4, it stops at this step. That is the beauty of reaction. So the Rosenman reduction is generally known for the conversion of acyl chloride into the aldehyde. So these are some examples. A Rosenman catalyst is poisons to stop further reduction on the desired product is obtained. Variety of poisoning can be employed for this process. An example for the method to totally deactivate palladium over barium sulfate catalyst is shown below. So this is naphthoyl chloride. Naphthobenzoyl chloride is reduces into corresponding aldehyde. Similarly, this kind of aryl chloride is also reduces in aldehyde. This is rare example. Double bond is reduced by using palladium catalysis.